Hey guys, hope everyone's doing okay. So this video is going to be for the qualitative graphs. So mainly if you were out on Friday, these will be the notes that you missed from class. And to go along with this, there's a copy of the notes. It says, it's titled Sketching a Qualitative Graph, and it's the student copy. So on Thursday we had talked about how to interpret a qualitative graph, how to read the behavior of the graph, the trend of the graph, to see if things are increasing or decreasing, if they're constantly increasing or decreasing, if they're staying constant, things like that. So now we're going to take that information and we're going to sketch our own graphs. So a qualitative graph, to sketch, we have four main things we're going to look for. And we're going to have 4 steps to go with it. So the first thing we need to look for is, what are we labeling? What are our units? What are we measuring? And sometimes there's more than one possibility. Sometimes there's maybe something that jumps out as something more obvious to be measuring. So we're going to draw our axis. So that would be like, having your y and your x. That's going to be your first step. Now with a qualitative graph, we're not going to have any numbers here, but we will have our graph looking like this. And then we're going to think about the situation that we have. We're looking for keywords. Is this a linear relationship? Is it not linear? Are we increasing? Are we decreasing? Are we staying constant? Things like that we're going to be factoring into our situation. And we need to picture what situation's going on. It might be a ball falling from a building. It might be a runner and we're measuring their speed or their distance traveled, things like that. So picture the situation that's going on and really think about your labels and how they're changing. And then your last step is going to be to successfully sketch the graph that represents the situation. So going into our second slide, we have a word problem about a hot air balloon. So it says a hot air balloon begins on the ground and rises at a constant rate. Once it gets to a certain height, it pauses so the passengers can enjoy the view. The hot air balloon then starts going back down to the ground, now at a slower constant rate than it rose at. And we want to sketch the qualitative graph. So, for our x and y axis, we're going to need to think about what are the units that we're measuring here. So the units here, we're going to end up measuring the height of the hot air balloon as time goes on. And it says the hot air balloon begins on the ground, so when time is 0, we're going to be right here on the ground. And we are told that the hot air balloon rises at a constant rate. So a constant rate is an indicator that we're going to have a linear relationship. So we're going to go on a nice straight line, constantly going up at the same rate. And eventually we get to a point, we don't know how much time has gone by, we don't know how high up we are, but we know at some point we are going to stop to enjoy the view. So at that point, time continues to go on, but the height is not changing, so it should stay constant going over. Now this first part of the graph, that was a constant rate. It was increasing at the same rate. The second part of the graph, the height is staying constant. So a constant rate versus staying constant. A constant rate, you're increasing or decreasing at that rate. Staying constant means you're not changing. You're staying at the same height as time goes on. And our last part says we go back down to the ground at a slower constant rate. So in order to be slower than this part of the graph, our line's going to need to be less steep than this. The steeper you are, the higher your rate is. So we want to be less steep than this because we have a slower rate. So this would be fine. And we don't know exactly how much slower it is, but we just need to make sure the slope is not as steep. So this would be our first example. This is our hot air balloon. So on to our next, this is slide number 3, and this one was about an athlete running. It says an athlete alternates between running and walking during a workout, and we're going to sketch a qualitative graph to represent the situation. So there are a couple graphs you could make for this one. In both graphs, we're measuring as time goes on. That was our x. And our y represented, I think we did both the distance traveled by the runner and the speed of the runner. So let's say for this one, let's say we do the distance. So we'll do distance. So the distance of the runner, distance traveled, we can write that. Because you could also do like the distance away from home or the distance away from the destination, and it changes the graph a little bit. We'll just say the total distance traveled. So in the beginning, the runner has no distance traveled, they're starting out. So they're starting at time 0, distance traveled of 0. And it says the athlete is going to alternate between running and walking in the workout. In class, we made a map of what they did. We said, let's say they walked first, and then they ran, and then they took a break, and then they walked home. And for all of these, we said that they were all at constant rates. So they're walking at the same speed, and they're running at the same speed, and their break is obviously going to be at the same speed as well. So if they walk first, whoever this runner is, their distance traveled as time's going on, they're going to increase. They're going to travel a certain distance as time is going at a constant rate. We said they're traveling at a constant rate. And then they decide after walking, that's the first part, they decide that they're going to now run. So at this point, they're going to increase their rate. So they're going to become a little more steep, meaning they're covering more distance, like more rapidly than over here. So a steeper slope. This would be the running part of the graph. Now they take a break, so they are going to stay constant. Their distance traveled is not going to go up or down. They're just taking a break. And then they're going to walk. Let's say they're walking home. If they're walking, and we're going to say they walk at the same pace that they walked originally, they should have the same slope here. We don't know exactly what the slope is, but we know we should be the same. And they're walking. We're still accumulating distance traveled, so they're still going up. The total distance traveled is still increasing. And then here would be at the end of their run when they finally stop walking. All constant rates, and here your constant rate is 0. You're not traveling any distance, you're staying constant. So this would be an example of our athlete alternating between walking and running and back to walking. On to our last one. This was slide number 4, and it is about a tennis ball being dropped. So let's get our y-axis, let's get our x-axis, and it says here a tennis ball is dropped onto the floor, and on each successive bounce, it rebounds to a height less than its previous bounce height until it comes to rest on the floor. And we're going to sketch a qualitative graph. So we're going to be interested in what happens to the height as time goes on. We'll do height for this one. And it starts out as the tennis ball is dropped, meaning it has an initial height. So your initial value is going to be not on the ground. We don't know exactly how high it is. We also don't have any numbers, so we don't know what this point represents. This could be 5 feet off the ground. It could be 100 feet off the ground. We don't know exactly where it represents, but it is off the ground. It's above the ground. And we talked about the height of a tennis ball. When a ball is dropped, and you talked about this in your science classes, gravity is pulling down, so the speed is increasing as it goes down, meaning it's not traveling at a constant speed, that its speed is increasing. So its rate is going up. It's not a constant rate that it's traveling at. So this, we decided, was not a linear graph, but it's going to be nonlinear. So when you first drop the ball, it's going down, but as it gets closer and closer to the ground, it's gaining more and more speed because gravity is accelerating towards the ground, and eventually it's going to come down and hit the ground. Now, once you hit the ground, what happens with the tennis ball is it bounces back up. So it's going to bounce back up, and it's going to go up and up and up, and it's going to come close to the same height. As it gets closer to that height, its speed is slowing down. if you want to relate that to your science class, its kinetic energy is turning into potential energy as it goes higher up. Eventually gets to its maximum value. If we're bringing in our quadratics here, that would be the maximum. And then it starts to come back down. All of that potential energy is now becoming our kinetic energy. And we're going to come back down, and we're going to bounce back up and follow this pattern. We'll hit our max height and come back down. So we're measuring the height as time goes on. Keep in mind, as this happens, we should continuously be moving to the right. At no point should we ever go backwards in the graph, because that would imply time is going backwards. So we should be still progressing to the right as we go, and eventually the ball will come to a rest on the ground. So this would be our tennis ball's height as time goes on. It starts out high and it bounces, comes back up, bounces, comes back up, and so on. Alright, so this is how we can sketch a qualitative graph. Just really picturing the situation, thinking how your labels, in this case height and time, are affected as, or in this case, your height is affected as time goes on. Alright guys, that's all you have. You're all caught up on the notes. Check back tomorrow for a new lesson. Enjoy the rest of your day.